Welcome to episode number 156 of CXOTalk. I'm Michael Krigsman, and today I am joined by Anthony Scriffignano, who is the Chief Data Scientist at Dun Bradstreet. Anthony, how are you today?
Hello, Michael. How are you? I'm doing great.
Hey, listen, thank you so much for taking the time. It's wonderful.
Not at all. It's my pleasure.
Anthony, let's begin by tell us some background about Dun Bradstreet. It's an interesting company, and it's been around for many, many years.
Yeah, it's a fascinating company to me anyway, and I think to many people. It's been around we're at 174 years now, so it started before the Civil War, and it's been through many, many different iterations over the years. Company has between 4,000 and 5,000 employees, but then we also have Worldwide Network and other partner associations around the world. So it's a pretty big company. Most of our customers focus on problems in the area of either total risk or total opportunity. So think credit and also sales and marketing, and then some of the related issues that you get like compliance and government relations, onboarding customers, things like that.
So very quickly, because I'm curious about this, you started before the Civil War, and I know that a number of presidents have actually worked for the company, including Abraham Lincoln. So what did Mr. Dun and Mr. Bradstreet, I'm assuming they were Misters, do before the Civil War?
Well, they were. And if you think about what was going on at that time, so you had westward expansion, and you had a lot of businesses on the East Coast that were trying to do business with people who were increasingly far away. And it got to the point where you couldn't go visit them and judge the character and quality of the person, or how real they were, or whether their operations appeared to be significant enough for you. And so they wanted people who could essentially be their representative in forming those opinions. And that's how this all got started, is help me understand people I can't see. And that's pretty much what we do now, except instead of trying to deal with the 2-month stagecoach ride, it's the 2-second trip over the internet, but it's the same problem.
So that 2-second trip over the internet comes down to data analytics and data science. So in a sense, back when the company was founded, there was the transfer of information, as you said, over stagecoach, and then there was some type of analytical method used to evaluate the risks. Now you use data science, and you're the chief data scientist. So what does that actually mean in this context?
Well, it's the joke would be, how hard can it be, right? The issue is that as you try to make a decision, let's take ourselves back to pre-Civil War days, right? What would you look at to try and make a decision about whether a business is quote unquote worthy, right? Well, the first thing is, are they real? And then you ask some questions about how long have they been around? What kind of business are they in? Well, we do the same kind of thing. But when you think about data science and you think about the literally millions of sources of data that are potentially available to make such a decision, how do you decide what's true? How do you decide whether what you're seeing is what it appears to be? How do you find that very small, very new business that just came into being? What happens when a business has a name or an address or a phone number or any kind of physical presence that's in some way transient or virtual? So the questions are really the same kind of questions, but the data science version of it is, how do you use new types of data as opposed to just new places where you can go look? But it's a very similar problem, but much more algorithmic, much more automated, much more quote unquote scientific.
So how do you use data to determine quote unquote what's true? That's the question you asked.
That's a big question. So if you think about what true means, sometimes that's relative, right? Suppose the question is this business out of business? That seems like a very binary thing. They're either out of business or they're not out of business. Well, not really. When you look at a very small business, they're not necessarily going to go bankrupt. They're not necessarily going to call us and say, by the way, we're going out of business now. They're not going to put a notice in the newspaper. There's not going to be any kind of press release. There's not going to be anything. They just stop. And then what if they just are resting for a while? What happens if a small business is actually still in business, but the proprietor of the business is just doing something else. He's sailing around the world for a year, or he's in the hospital, or she decided to go and do some other business for a while and she'll be back, right? So we have these versions of kind of parking as opposed to definitely done at a business. And that's a very nuanced kind of thing. So how do you figure that out with a stream of data? Obviously, you could look at suits, liens, judgments, business deterioration, look at those things as precursors to businesses that really die, as opposed to things looked like they were going well and all of a sudden they stopped. You might look at the type of business that we're talking about. You might look at the location in the world. You might look at the owner of that business in the context of the business and see if you see them popping up elsewhere. There's lots of different signals that you might get in a situation like that.
So explain how you go about, as a data scientist, how you go about analyzing some of these problems.
Well, let's take the issue of fraud as a great example. So fraud, when we talk about it, we think we know what we mean, but everybody means something different. So fraud, by any definition around the world, is some sort of misrepresentation of information for financial gain. When people lie to us, they haven't gained anything yet. So is that fraud? We call it malfeasance sometimes. If you think about the problem of fraud in the context of how you see it in data, or even how you see it in real life, it's what's often referred to as a quantum observation problem. When you observe it, it changes. So people committing fraud behave differently when they know they've been detected. And so to try to use regressive methods that only look backwards at pre-existing data and pre-existing examples of fraud, you'll get very good at catching the things that used to happen, which is counterintuitive because the thing you're looking at, is changing. So data science would say, yes, do that because it's not going to completely stop, but it's necessary but not sufficient. You need to do more. So how do you find types of bad behavior that haven't occurred yet? Well, the first thing you do is you look for types of behavior you haven't seen before, and then you try to vet those behaviors against behaviors that are known to be malfeasant to try to see if there are similarities. And data science provides non-regressive methods to do things like that, looking at connected space, what we call dyadic relationships among multiple parties, and looking for observable relationships that are different than the ones we've seen before. And then that allows us to focus and address a problem like that. So it's a very long way of saying you start looking for things that are new, and then you start to unpack them and see what they tell you.
But you're doing more than just simple comparisons. In a sense, if I can incorrectly boil down what you just said, was we compare that which we don't know to that which we know.
Exactly.
But that seems like a fairly trivial observation, and so I assume that the data science part is quite a bit more involved than that.
Yes, absolutely. So the part we don't know is where all the challenge lies, right? You have so much data in front of you, and you have to make a decision which parts of it are you going to look at and which parts of it are you going to not look at. There's a huge opportunity cost to making a decision like that. You can't just bring in all the data and keep pressing the learn things button, right? So every time new data becomes available, there's the step of discovering, realizing that it's available. There's the step of curation, making a decision about whether or not you bring it in, and if you did, what would it mean? And by the way, are you allowed to bring it in? Do you have permissible use? Things like that. And then there's the synthesis, making sense out of that. And that all sounds easy until you try and do it at the scale of the creation of information, which is off the chart. There's so much information being created right now that we've actually lost the ability to measure the rate at which it's increasing. Not only don't we know how much information there is, we don't even know how fast it's growing anymore.
Okay, discovery, curation, synthesis. Can you give us an example, give us a concrete example from your work that ties these pieces together so that we can understand the data process, the data analysis process that you go through in order to learn something new from the data that you didn't see before?
Sure. So let me give you an example that seems obvious that's not. Let's suppose that we're trying to understand how a company represents itself around the world in different languages and different writing systems. So you might think that you just translate, but translating works really well for proper nouns, for common nouns, but it doesn't work very well for proper nouns. So if you have your own name, how do you represent yourself in in Arabic or in Chinese, or those are decisions you have to make. And they involve sound, and they involve the interpretation of maybe the symbols you might use, or how those sounds sound in different languages, etc. Different languages have different phonetic palettes. My name, Scriffignano, has a GN sound in it, the nya, that's not an English phoneme. So, when I tell people how to say it, I say, well, say lasagna, because you already know how to say that, right? So that's a sort of a technique, right? How do you now discover the presence of an organization or a person in different parts of the world when they're represented differently? You can't just sort of flip the letters around, especially when we're talking about different writing systems. So one of the things that you do is you ingest a very large corpus of information that you understand. So you might ingest something like, think about like maybe a chamber of commerce might produce a listing of the directors and officers and CEOs and owners of businesses. So now I found a listing of a whole bunch of names. And I have, let's say, a listing of a whole bunch of names. The curation is trying to make a correlation between those two, saying how much of this thing that I just ingested that's in a language I don't know can I understand from sort of the context that it's in? And then the synthesis is, can I discover any rules? So I'm just thinking of an example. In Greek, they have the letter he, which sort of looks like an X. That sound doesn't really exist in English. Does that turn into a CH, or does it turn into an X, or does it turn into a K? And those three different decisions will lead you down a different path. So now once I have that question, is it C, X, CH, X, or whatever K, now I can start to look at the data that I have and say which seems to me more appropriate. And over time, I can develop rules. And then over time, those rules can inform new processes. I can tune those processes. I can do what's called heuristic analysis, where I get a group of people to observe what the machine is doing and see whether they agree or disagree. And you tune these things over time, and eventually it sort of approaches the collective experience of a person doing the same thing. There's a thing called the Turing test. You might be familiar with it. Is the ultimate example of that. At what point does it appear to you to be intelligent?
So at what point does it appear to you to be intelligent? At what point do you make the decision that all of this analysis, this normalization of multiple data streams, all the analysis that you're doing, that you've done enough, and now, based on that analysis, you actually do know what is quote unquote true?
So true is a very dangerous word, but what we're looking for is we're looking for something to converge on a group of, in the case of heuristics, what's the gold standard is a group of similarly instructed, similarly incented people. So you look at a large enough collection of information, and you make sure that you ingest and interpret that information the same as a group of people who are similarly instructed and all have the same to gain or lose. You can't have like 10 experts and 5 interns. They've got to be kind of the same. And then there's some techniques for normalizing for optimism and pessimism and fatigue and things like that. And eventually what you get is not something that's necessarily always true, but we like to use the phrase that consistently wrong is better than inconsistently right. Get to something that's consistent, that you can continue to tune as you understand how it behaves, and you either like or don't like what it's doing.
So the first step then is to aggregate a large amount of data, what we commonly hear the term big data.
I'd say the first step would be to become aware of the data that could potentially be aggregated.
So what does that actually mean?
Don't try to eat the whole salad bar. Don't take everything in. Look at what's available and decide what you're going to need for your salad, and have a reason for deciding that.
So you have to be clear about the problem that you're trying to solve.
Exactly. It really goes back to, you never lead with the data and you never lead with the technology. You lead with the problem. Now, there are times where you might pull in the data and say, what can this data tell me? But in general, for a business problem, you should start with the problem. You should start with, what's the real thing that you're trying to do? I have used examples with you of discovering fraud, or finding new businesses, or discovering when businesses have died. Those are real business problems. You start with the problem. And then from there, you look at the data. There's the sets of data. There's the data you already have, the data that you could go out and discover, and the data that you're never going to get to. And you have to evaluate the relative size and importance of those 3 classes of data against the problem that you're trying to solve.
So we hear this buzzword, big data, all the time. What does big data actually mean in the context of your world as a data scientist who's looking at these large blocks of data or aggregations of data in a more rigorous way? So I guess compare big data as a marketing phrase versus a large volume of data. And I've heard also you use the term smart data in making this comparison.
Yeah, I can only define smart data as juxtaposed to big data. So let me take the first predicate in your question first. So big data, we jokingly refer to it as now because you're almost not supposed to talk about it anymore, but it hasn't gone away. Big data is described in many different ways. What I try to do is describe it very formally and very empirically, very consistently. So you'll hear me say that you have these aspects of volume, velocity, veracity, variety, and value, the V's. And you have a big data problem when those V's overwhelm the best attempts to deal with them. That doesn't mean you're too cheap to hire the right people or you have the wrong technology, but when you throw the best of the best at it and you're still overwhelmed by one or more of those V's, now you have a big data problem. So it's not just having a lot of data. It's not just having data that's changing really quickly. It's not just having data that some of it's true and some of it's not and you can't tell the difference. It's all of those things more or less at the same time. And when they start to overwhelm the system, that's when you start to have a big data problem. Smart data, some people use that term to differentiate between the big data and the smart data. The smart data is the subset of that data that will actually apply to your problem, that can be used intelligently in a way that takes you toward a solution. And I would add to that definition, it doesn't necessarily have to take you toward a solution. It could also take you toward breaking a large unsolved problem down into a smaller problem that's still unsolved. Think about like curing cancer, right? You may not cure cancer, but you may say, all right, cancer has nothing to do with the color of your blood. All right, moving along, right? So you've taken the problem and made it smaller. And then the other thing about data is, or about that journey is, it also might be data that uncovers a question that you forgot to ask before. So, we've been focused all along on, are there planets outside our solar system? We kind of decide that there must be, logic and epistemology says there has to be, but until very recently, we couldn't prove that there were any exoplanets. Now, all of a sudden, we have tens of thousands of exoplanets that we know about. So the next question along the way is, well, do any of them look like ours? That's not the only next question, because someone could say, what's so special about looking like ours? Might they look like something else and still be of interest? So you get these two classes of people. One class is looking for water and the other class is looking for a certain planetary mass. That's an example of taking a big first asking a question you forgot to ask, and then taking that question and breaking it down into a smaller question that's still unsolved, but it's moving you toward an answer.
We have an interesting question from Arsalan Khan. So
nothing to do with exoplanets, I assume.
I suspect you may be able to make a linkage here. But I'll let you do that one. So you mentioned that this concept of truth is a rather tricky concept, and there is no ground truth necessarily. And so he's wondering, you as a data scientist come up with your conclusions, and then an executive in the company looking at those conclusions say, no way.
Right.
That's not a chance. Your data's wrong. Yeah. Because that's not the truth of the world. The truth of the world is this over here. And what do you say to that?
Well, first I say that if I started by saying, here's the truth that I've discovered, then I deserve that kind of a reaction. So data science is about the data part, but it's also about the science part. And we have this thing called a scientific method. So it means that we observe the world around us. We form a hypothesis about that world. We ask a research question. We look at what literature is out there, like what everybody else has done first. We then pick a method to answer our question. We prove that that's the best method. Then and only then do we go out and collect some data and use that data according to our method to answer our question. We talk about the answers that we've concluded. We talk about the bias in those answers, the weaknesses of it, and we support our answers. And then if we're really good, We ask questions for future research. So if we did all those things, I don't just go to the leadership in my organization and say, I think this data proves that there's life on other planets. I go to my leadership and I say, I asked myself the question, is there life on other planets? I said, well, life as we know it right now is based on water and some other things. So what I did was I looked for evidence of water. Here's how I decided to look for evidence of water. I looked for hydrogen and oxygen or whatever you do. And here's what I found. Here's what I think it means. Now, if you disagree with me, tell me what you think I got wrong. Did I get the wrong question? Did I understand the data wrong? Did I use the wrong method? And if they can answer any of those things, then if I'm a good scientist, I should be able to respond to those things. That's called defending your hypothesis, right? If I can't respond, then I've done bad science. And then shame on me.
So, yes.
And I snuck the exoplanets in there.
Yeah, so you're one of those tricky ones because, yes, I, playing the role of an executive, I hear everything that you're saying. I see your data. And yet, looking at that planet, it sure looks like it has a pinkish cast to me. And in fact, I know that it does. And I've been working with planets that have a pinkish cast or sets of data like this one my entire life. I know this population. And you are now telling me something through your scientific method that contradicts firm beliefs of how I see the world, and I know the way the world works. What about that?
So, Michael, let me respect your knowledge of pink planets. I really appreciate your observation and your experience, and I'm certainly not calling you wrong because what you believe is what you believe. Help me understand how you've come to have this opinion about the relationship between life and pink planets. And pretty soon what's going to happen is you're going to be saying, well, it just is. It's in my experience. And I'm not calling you wrong. I'm asking you to help me understand why you believe what you believe. So if we're really going to be scientists, then that means that we have to be open to conflicting opinions. And if we're open to conflicting opinions, those people who have those opinions should be able to defend them. Now, sooner or later, you can say, look, I'm your boss, and what part of I'm your boss did you fail to understand? And go back and prove my pink planet hypothesis, right? If you go and tell me what to go prove, you're basically asking me to engage in bad science. And now we have a whole different problem, right?
Boy, it sure sounds like a lot of businesses I know.
Yeah, it does. It sounds like a lot of I've worked with. Fortunately, not the one I work for right now, not at all. But you also have to be very careful. You can be right and dead, right? So part of being a good data scientist is being able to use what you've learned to tell a story that credibly approaches a problem that somebody has. You can't just walk in and say, oh, look, I used all these great methods and look what I learned and you should bow down to the data. Absolutely not. You have to understand the problems that people are trying to solve. You have to understand how you can be relevant in the context of those problems. You can't always do all of those steps I just articulated because time and money and reality are going to get in the way sometimes. So you have to be reasonable and practical. But by all means, you have to be empirical. You have to do something that you can repeat. You have to do something that you can defend. You should never use the fact that someone's in a hurry or is shouting loudly to go and do something completely irrelevant or negligent. You have to be very careful. There's a lot of solutions out there that will let you just ingest a ton of data and push the magic button and reach some kind of a conclusion. And that's great. I mean, sometimes that's all you have. You don't even know. You have no idea what this data means. But at some point, you have to do better than that. A great example is if you just didn't know anything about playgrounds and you drove past a playground and you saw a bunch of kids playing in the playground, you might initially conclude that this is chaos. It's just a bunch of kids doing stuff. If you observe the playground more closely, you would see a baseball diamond or a football field. You'd see lines. You'd see, things that imply some sort of structure. And you might, if you looked closely, see playground monitors. You might see people there that are enforcing rules. You might see that the little boys and the little girls are doing different things or playing differently. You might start to uncover behavioral aspects. By using correct observational techniques and being careful about what you see, you'd learn a lot more about that playground. Now, you can yell and scream and say, I've looked at playgrounds all my life, and you absolutely never see business being conducted on a playground. And I said, well, that's great. What about those two guys in the suit over there pointing at the foundations on the jungle gym? Oh, well, those are contractors. They're not kids. Well, you didn't say anything about kids. You were talking about playgrounds. We got to make sure that we understand what we're saying to each other.
So you were talking earlier about connected spaces and people and relationships. Can you elaborate on what do you mean? What is a connected space in this context?
Well, great question. So you have to be very careful when you use a term like that you know what you mean. Things can be connected in many, many different ways, and even defining what a connection is somewhat problematic. One of the things that we talk about, and what I talked about before, is a dyadic relationship. It's a relationship between two entities. So at Dun Bradstreet, we mostly talk about businesses. A connected relationship might be ownership. So you have a branch and you have a parent of that branch. You have a subsidiary and a parent. So you might have, we define it in one type of linkage that we have as majority ownership. So if there's a subsidiary, it owns more than 50% of something. That would be a type of dyadic relationship. Another type of dyadic relationship among business entities might be that they've sued each other, or that they've mentioned each other in social media, or that they have co-collaborated in some observable intellectual property, or that someone from one company is connected to someone from another company on a platform like LinkedIn or Facebook or something like that. Those would all be types of discoverable dyadic relationships. And then the question is, how can you observe all of those dyadic relationships and how they're changing over time to form conclusions about things, like maybe the business is growing, or that the two companies are collaborating, or that the two companies are adversaries, or that there seems to be some kind of fraud or malfeasant behavior going on. Those would all be conclusions that you might try to reach through observing those dyadic relationships. There's other relationships that are more than one-to-one. They have different names and they have different problems and uses.
Give us an example of something that's really hard. What's the hard kind of problem that you face? And maybe talk about it in a business context.
So hard always is involved when people's behavior is involved. So fraud, we keep talking about fraud. Fraud is hard because bad guys keep innovating while we're innovating in how we detect the behavior of bad guys. That's a really hard problem. Another example that involves behavior is when businesses have connections to each other that are not formed through owning pieces of each other. So they form temporary relationships, alliances, they form groups, they form, lots of different words for you have to sue us separately. Like we're not part of the same thing, right? Really hard because they're very squishy kind of things. Anything that involves behavior is not observing a strict set of rules that you can go and discover.
So it's when the connections, when either you have the human element or there are connections that exist, but the companies have been structured to reduce or eliminate to the extent possible direct business connections, even though there are relationships there.
Sorry, yeah, there may be intent like that and behind it, or it might just be something that's happening sort of organically. If you think about sometimes when there's an external event like a flood or the Arab Spring or some major change in who's in charge of the country or the region or whatever, all of a sudden in the business world you see a lot of shifting around, and it's not like everybody gets together and says, okay, how are we going to react to the fact that there was an earthquake in Taiwan? It's just that there was an earthquake in Taiwan, and now some businesses start doing things for humanitarian reasons. Other businesses start seeing opportunity where it didn't exist before. And you get this, I don't want to say chaotic, but atypical behavior. And to say that you're going to model that behavior, maybe if something very, very similar has happened in a reasonably recent period of time against the same type of universe, you might be able to do that. But usually all of those preconditions aren't met. So you have something very squishy and it involves behavior, and you have to respond to it or choose not to. Either one is a choice.
And how do you make the decision of which data problems to solve? Since you mentioned that's really the first question. How do you decide what's a good data problem to be looking at?
Well, to be looking at and to solve are two different questions also. I have to kind of parse that. But, there are some guiding principles. So we have general guidelines. I call them foul lines. We don't just do things because they're fun or interesting or scientifically challenging. There's got to be some real business frame for it. At the beginning, I talked to you about total risk and total opportunity. So at Dun Bradstreet, normally we look at things like that. We look at, on the total risk side, it usually has something to do with, are they going to pay? Are they going to stay in business? Are they going to commit some kind of malfeasant act? Are they going to in some way threaten some business objective? On the opportunity side, it's how big are they? How much do they look like my best customers? How much do they complement my best customers? What's the white space in this industry? Those are all opportunity kinds of questions. So normally I would start from one of those frames. If somebody just said, here's this really cool language problem and you guys do a lot of computational linguistics, wouldn't you like to, look at Arabic? Well, yeah, of course I'd like to look at it, but do I have any data to look at? And is it part of a problem that our customers have? And would anybody notice if I made any progress there? And, if the answer to any of those is no, you probably ought to move on or at least keep an eye on this and come back to it later.
And a different question here altogether. What's the relationship between data science, big data, artificial intelligence, machine learning? We hear these buzzwords thrown around, and usually they're thrown around by marketing departments. So from a data science perspective, what's going on with that?
Well, artificial intelligence and machine learning are tools that are used by data science. So some of these things that you hear about, neural networks and quantum algorithms and machine learning, and those are all tools and techniques that can be applied in the field of data science. Data science is a complex combination of being able to understand the methods for understanding data scientifically and also using it to tell a story. And in the business world, that story has to relate to a real problem that is meaningful to the population. So if you think about data science as the part where you use all of those other things, and I would also add, very often misuse all of those other things because you've been either tricked into using them by somebody who says that they'll solve all of your problems, or you are, hoping that somehow that's going to be your silver bullet, or you've been in a conversation that started with my favorite words, why don't we just, and we'll push this button and everything will get easier. So, there's a sort of a dark side to all of this, that you'll go and use all of those tools and techniques without really understanding what you're trying to do. That would be like me going into a hardware store or into a tool store and buying a laser, saw that does, and I'm not a carpenter, right? Well, that's great. You have this tool and you're trying to carve a pumpkin. You bought the wrong tool. Like, you need to understand what you're trying to do. You don't just jump right to the tools.
So data science is about telling a business story. Is that the ultimate goal? Is that your end objective in a sense?
Using data to address a problem and to be able to answer that problem in a way that's meaningful to the business. And what I would add, the science part, is in a repeatable, defendable way. Many people would not add that last part, but I would.
So the defeatable,
repeatable. It's often defeatable as well, but that's another problem.
Well, if you go through the steps you've been describing, then hopefully it's less defeatable and more repeatable.
Yes, we should hope so. Yes. Yeah.
So what about innovation? Right now, the Internet of Things, innovation around data seems to be where the future is taking us. Maybe give your point of view on that.
Yeah, so thanks for that. It used to be a couple of years ago, if you wanted to be a pundit and talk about technology and where we were going, you had to say mobile, social, cloud, analytics. You had to get those 4 words out. And what I've been saying recently is that, those 4 words lead to lots of other words. So, if you're going to talk about mobile, you better talk about the Internet of Things, right? Mobile technology is just sort of things that are out there and moving around. And the Internet of Things, some of those things move around, some of them don't, but they're certainly out there. And we may not necessarily know where they are or what they are when they're talking. And that presents a whole slew of problems. Just like if you talked about, I don't know, cloud computing, you better be talking about data sovereignty and, the different rules and regulations of, you can't just put data out in the cloud. Nobody thinks there's hard drives floating around in the cloud, right? That data sits somewhere. So your question was about the Internet of Things, which to me is an extension of, where we were a couple of years ago. I think a lot of people think this, that we've got a thing or two to learn in this space. If you look at Bluetooth from a number of years ago, I think there's a good analogy. Bluetooth was sort of invented, and then it took about 10 years to catch on. And part of the reason was, in my humble opinion, we forgot to think about a number of questions. Like, it's great that you can have a Bluetooth headset, but how do we keep my headset from discovering your phone and eavesdropping on it, right? Well, we'll put this 4-digit passcode in there, and then nobody knows the number, so they're always 0000 or 1234, and then all of a sudden, all you have to do is try a few numbers. And so, we've got to be better than that. With the Internet of Things, we've got, tens of thousands, hundreds of millions of things right now, talking to millions of other things. And we're sort of making some of those same mistakes. There was a big issue not too long ago. I won't name the company, but there was a doll. And the doll could talk to a cloud application. And your kid could talk to the doll, and the doll sort of seemed to know what was going on. And it would get smarter as other kids talked to the same doll. That's great, except someone realized that was a device on the Internet of Things that had an IP address. And if I can hack into it, it has a microphone. And if the kid leaves the doll in the parent's home office, I can eavesdrop on the conversation and maybe short stock or do things that are malfeasant, right? And then that started to happen. Whoops, didn't think of that, right? So if you're going to build something on the Internet of Things, you better be thinking about how it might be used in unintended ways. You also better be able to think about what happens if it's used in intended ways at a scale that goes way beyond what you ever intended. You also better be able to think about how other people might use it to solve unknown, unmet needs. Somebody starts to use your thing to solve a completely different problem that you didn't plan on it solving, and you didn't build it for that purpose. And now all of a sudden you're negligent in a way that you didn't even intend. We've got to be a lot smarter about this. We can't just rush to say, oh, isn't it great that things can talk to other things? Yes, but what might they say to each other? And how might they all of a sudden help people do things we didn't intend? Very big questions. We better be asking those questions.
And as you were asking those questions at Dun Bradstreet, what are some of the answers or the points of view or the trajectories that you're coming up with?
Well, so things themselves don't necessarily play into our landscape right away, although some of those things might talk to us and ask about businesses. I won't get into the complexities, but there's ways that things can ask about businesses, right? The reality is that the only things that we foresee asking us about businesses right now are other computers. So we worry about the transactional response time of that question and answer and the ontology of the question and the ontology of the answer, and all that's great. But now, do we do anything to detect what type of thing might be on the other end of the question? And, without getting into any security, there's things that we do today to make sure that the thing that we're talking to is something we intend to be talking to. We've got to do a lot more ideation to make sure that what we believe remains true as things get smarter and talk faster and find new ways to whisper in our ear and all of that. So just like any other company that touches the internet, you just can't say, well, we were safe yesterday, so we'll probably be safe tomorrow. That's crazy.
What advice, as we go towards the close here, what advice do you have for business people to use data science effectively?
So maybe I could tell you a quick story about something that happened in my experience here that literally has changed my life. A number of years ago, we had this horrible situation in Japan where there was an earthquake that caused a tsunami. The tsunami hit the coast of Sendai. 20,000 people were washed out to sea. You had a nuclear meltdown at the Daiichi nuclear power plant. You had all these things happening to Japan all at once. Absolutely horrific, unprecedented. No data science in the world ever foresaw anything like that happening, right? And here we are, we come together. I was on a conference call a few days later. I was actually in Japan right before that happened. And we said, look, we can do things from a humanitarian standpoint, but also from a business standpoint. There's got to be something we can do to help these mostly small businesses in Japan that are kind of living hand to mouth that everybody assumes are now out of business. Many of them are still in business. Many of them are still there and doing fine. And if everybody assumes they're not, then things are going to get even worse. On top of radiation and tidal waves, they're going to have to deal with no money. So we started to look at a database that said everything was just the way it was right before this happened. To fix it the old-fashioned way was going to take a very long time, way longer than these people had. And so we had to look at new ways of collecting information. We started to look at new types of data that were available. We looked at crowdsourced radiation data. We taught algorithms how to find the skyline, to measure the change in the skyline before and after. We looked at uninterrupted straight and curved lines that became interrupted in geospatial imaging. We looked at the propagation of the tectonic wave from the epicenter of the earthquake. And we built 19 different car detectors to measure whether or not cars were there and what they looked like. Now, you could argue some of that capability already existed, but we didn't have time to go find it. And very quickly, we put all of this together. We built a heuristic like I described to you before. We taught it how to look at the data, and we fixed all of the data for Japan in about 3 months. And it was going to take well over a couple of years to do it the old-fashioned way for very good reasons. We then had this data set that was probably the most valuable data set you could own at that point relative to Japan. We probably could have made a lot of money on that. And what we did was we put it on the internet and gave it away for free. And every time I tell that story, I get tears in my eyes. So my very long-winded answer to your question is we've got to be better than just making another dollar. We've got to think about the unintended impact of doing nothing. We've got to think about letting the bad guys get ahead of the good guys. We've got to think about what we're teaching our kids. We've got to think about what we're teaching ourselves, or we're going to just drown in this data and lose unbelievable opportunity and find ourselves just swimming in stupid decisions because we didn't have the time to do anything better. We're much better than that. And I truly believe that if we bring science into the room, we can at least make new mistakes every day, which is a very good start.
And finally, what words of advice do you have to business people who are dealing with data and they're finding that the data is pointing out viewpoints on the world that are different from their previously held beliefs, and we know change is hard. So what advice do you have there?
So I would say 3 things. First of all, just knowing that you have that problem is the first step. So being what's called a reflective leader, thinking about what you believe and why you believe it is extremely important. Your example of the guy with the pink planets before screaming that he's got lots of experience, that's great, but we've got to be better than that. So the first thing is to be very clear about what we believe and why we believe it. The second step is once we understand that, and presumably we can ask better questions about the business and what we're trying to prove and all of that. The second step is to look at the skills that we're bringing into the organization and make sure that we're not just bringing in people that have rebranded themselves in this data science space, but people that really understand the different ways of knowing, the different methods of discovery, the different issues with regulation and with synthesis of information, bringing in the skills that we need. And the last thing, and probably the most important thing, is constantly looking inward at ourselves and making sure that we understand the skills that made us successful so far. Those are just table stakes. We've got to constantly be improving. This is a whole new world out here, and we got to have these conversations. They're tough. But, you're not as good as you think you were, because you got to be much better than that tomorrow to just stay where you were.
Anthony Scriffignano, Chief Data Scientist at Dun Bradstreet. What can I possibly ask you beyond your last comment? Thank you so much for taking the time today. It's been enlightening.
It's been a delightful conversation. Thank you very much for the opportunity.
We have been talking with Anthony Scriffignano, who is the Chief Data Scientist of Dun Bradstreet. What an amazing conversation. And I'd like to thank Anthony and thank the folks at Dun Bradstreet for making this possible. And especially to everybody who's watching, thank you. And come back next time, because we'll be here next Friday, as always.